In this video, we'll be talking about fractions, and I'm going to start out by showing you a visual representation of what fractions mean. In the past, you may have heard of fractions as a part over a whole, but what does that really mean? So let me draw an example here. Okay, so let's say that we had this first pie cut into two pieces. What if I then shaded one of those pieces? Okay, so when you look at a fraction, you have the bottom, which is the denominator. And then you have the top, which is the numerator. The denominator is talking about the total number of pieces in something. We don't care whether they're gone or whether we have them. It's just what was something cut into originally. Okay, and I like to think in terms of pies or cakes, maybe because I'm hungry all the time or because it's something that I encounter somewhat regularly in life. So it's easier for me to visualize. So this first example, the denominator is 2 because there are 2 total pieces that pie was cut into. Now I've shaded part of that, so that shaded part refers to one of those 2 pieces. So that's what a fraction is, right? The number on the bottom is the total number of pieces. The number on the top is what part or the number of pieces of that total that something's been done to. Now there's something called equivalent fractions. So notice right here, right, I have equivalent fractions. So that means that the 2 fractions are actually the same quantity. So they look different, but they refer to the same amount. So I am going to draw another line here. This one I'm doing in blue. Okay. So now I'm going to look at that pie and I'm going to say, well, now there are 4 total pieces. Okay, so again, 4 would go into the denominator, right? And now of those 4, how many are shaded? Well, I have this one and this, which is 2 pieces. Right? So 1/2 or 1 out of 2 is equal to 2 out of 4. Okay? And then you could keep going. I could cut those in half again. Right? Okay, and now we have a total of 8 pieces. So that is our new denominator. And then we have 1, 2, 3, 4. So 4 of those 8 are shaded. Okay? So that is how to visualize what a fraction is, and then also how to identify equivalent fractions. So again, equivalent fractions are fractions that are the same amount. It's just cut into a different number of pieces. Okay, so now I am going to challenge you to pause the video and create a picture in the other pie that represents, let's say, 3/4. Okay, so I want you to figure out how many total pieces and then what part of that. And then I want you to also figure out, well, what if we had 8 pieces? Then what would your numerator be? So again, go ahead and pause the video, figure that out, and then I'll go ahead and do it for you. So we're drawing a picture that represents 3/4 and then also a denominator with an 8 and some numerator. Okay, so first of all, I care about the number in the denominator. And again, that tells me how many total pieces is my pie cut into. Okay, so I'm going to draw my line. There's 2 pieces total. Here's 3 pieces total. All right, or 4 pieces total. Now, I need to do something to 3 of those pieces. So I'm going to go ahead and shade 3 of those. So now 3/4 of the pieces are shaded. Okay, so that represents the 3/4. Now, what if I did a denominator of 8? So that means I need to cut each of these into 2, right? I'm doubling the number of pieces that I have. So there's 2, 4, 6, and 8. Now to figure out the numerator, I am going to count how many shaded pieces I have when I've cut the whole pie into 8 pieces. So I have 1, 2, 3, 4, 5, 6. So my numerator is 6. And then I could cut them each into 3 or each into another 2 pieces, right? And as long as my total number, that denominator, and my numerator are increasing by the same amount, you will find your equivalent fraction. Okay, so we don't always have to do this visually. We have a mathematical way of converting or changing from one fraction to another. So I want you to go back and look at the combination of 1/2 to 2/4 to 4/8. And remember, I made a comment that when you change the total number of pieces, you're also changing the numerator. So mathematically, notice what's happening is here, if I multiply 2 by 2, I get 4. So I'm going to show 2 times 2. Well, if I do something to the bottom, right, so if I cut all of the pieces into 2, that also means I'm cutting all the pieces related to the numerator by 2. So I have to multiply by 2. That gives me 2/4. So now moving to the next one, we went from 4 to 8. Well, again, I need to multiply 4 by 2 to get 8. And then I need to multiply 2 by 2 to get 4. Okay, so going to the next one, we have 4 times 2 gives me 8. Well, if I multiply the bottom by 2, I have to multiply the top by 2, and that gives me 6. So that might feel familiar because when we're finding common denominators, which we'll be talking about soon, this is what we do. We figure out what's going to make both denominators the same. We multiply the top and the bottom by the same amount and get our equivalent fractions with the denominator that we need. Okay, so this may be a little different context or different place that you've used this strategy, but it very well might look familiar, and that's why, because we do use it in adding and subtracting fractions. Okay, so now, instead of looking at a pie, we're just going to look at the fractions and do that question of what do I multiply, in this case, the numerator by to get the new numerator. And we want multiplication because we cannot change the value, right? And notice, let's see, if I focus on this one for a second, I am multiplying by 2 over 2. Well, 2 over 2 equals 1. So you're doing the same thing as multiplying each of these fractions by 1. And because of the identity property, 1 times anything is itself. So you have to do multiplication, and it has to be the same thing top and bottom. Okay, now it has to be multiplication when the numbers that you're starting with are smaller, and then you're going to a bigger number. We'll do the same thing, but we can use division if we're starting with bigger numbers and going to smaller. Okay, so 2 times what gives you 10? Well, 2 times 5 gives me 10. If I multiply the top by 5, I have to multiply the bottom by 5. So I get 10 over 15. Now, what if you didn't know what you multiplied 2 by to get to 10? You can always take the number that you're going to, so 10 in this case, divide it by the number you're starting with, so 2 in this case, and then you simplify that and you get 5. You get the number that you need to multiply by. So that's a handy little trick. Number that you're going to, right, divided by the number where you're starting, and that gives you the number you need to multiply by. Okay, So for 20 over 30, so we are trying to get to a denominator of 6. So the number is smaller, which means I have to use division. So I'm going to be dividing the top and bottom by something. Well, if I divide 30 by 5, that gives me 6. So if I divide the bottom by 5, I have to divide the top by 5. And I get 4/6. Now you can do the same thing. Previously, we did the number we were going to, right? The 10 divided by where we were starting, and it gave us the number that we needed. Well, here we can take the number where we started, 30, divide it by the number we're going, and that gives me the number I need to divide by. So you can use the same strategy, right, to figure out what you need to do. Multiplication if your number is getting bigger, divide if the number is getting smaller. All right, so take a moment and try C, and then turn the video back on and watch me go ahead and finish this one out. Okay, so here I need to figure out what I multiply 9 by to get 27. So I'm going to do 9 times 3. And again, if you're not secure with your multiplication tables, first of all, make sure that you practice them. And then secondly, divide 27 by 9, and that gives you 3. And then whatever I do to the bottom, I have to do to the top. So my final answer is 21/27. All right, so that was a visual representation of equivalent fractions and also the meaning of fractions, and then how you convert from one fraction to an equivalent fraction, depending, being given either a numerator or denominator that you're trying to get to.